Hi guys, it's going to be your first physics lecture in this course, and it's about kinematics. What is kinematics? Kinematics is simply describing the motion by using different representations, graph, math, verbal expressions, like that. Alright, and before we start, we need to talk about two different terms. You might have seen those terms in math, scalar and vector quantity, but they're going to be used a little bit differently in this class. Scalar quantity means it's a physical quantity, and it only has numbers, alright? The only thing that matters is number. Time, you don't have positive, negative time, you just have time. Speed is one of them, or like the temperature. You might have positive, negative temperature, but the definition of those positive and negative temperature does not tell you any direction. So vector quantity is how it's different from scalar quantity. It is going to talk about a number, but it's also going to talk about a direction. So there's no positive, negative direction for the temperature, so it's going to be a scalar quantity. But what's a vector quantity? We're going to talk about velocity. Velocity is 200 meters per second, but it's not going to be velocity alone. You need to include the direction. If you include the direction, it's going to be velocity. If you don't have the direction, it is going to be speed. And acceleration will also be a vector quantity, and I'm going to be giving the definition of those in a second. All right, position, it's basically relative location, and you can have 1D, 2D, and 3D directions. So X, Y, and Z, these are basically our coordinates to describe motion in 1D, 2D, or 3D. All right, distance, total length of a path followed by an object. So if you're starting from at that point, and then if you're following this path, then once you are basically measuring the entire length of this guy, this is the distance that you travel. It is a scalar quantity, so there's no direction, so only number is important, and the way that we measure that distance is using the meter. And the symbol for distance can be x, y, z depending on the x's of the motion. Alright, displacement. It's also related with distance, but it is displacement. So you are basically have a location and you have another location. So those 2 points are the only 2 points that you worry about when you're calculating the displacement, because it's the length of the straight line in between those initial and final points. So this distance, if you want to call it, is going to be your displacement, and the way that we represent displacement is delta x, or that triangle, and that triangle Greek letter, it's basically delta, and that delta function is going to be very, very, very important for the rest of the course because we're going to be using it in different places. Delta is going to be the difference in between the final and initial values of the variable. So in this case, my variable is delta x. So what does that mean? You're going to look at initial and final locations of that variable, and then you're going to subtract the initial from the final. Alright, so that's the definition of that delta. And displacement is only going to care about the initial and final location. So it doesn't care about the path in between. So let's say you are going that much of a distance. So the displacement of that guy, you don't care about the total length, you just care about initial and final location, and that's your displacement. Alright, what's your velocity? It's rate of displacement, which means how much you displace over given time. And if you want to make it delta, like explicitly, then x final minus x initial divided by t final minus t initial. Or informal definition is speed with a direction, and it's also a vector quantity, and the way that we measure velocity is meters per second. So how much meters over a second? Meters per second. Acceleration is rate of change in velocity. All right, this is important. You're not just talking about velocity, you're talking about a change. If there's no change in velocity, then you have no acceleration. It's a vector quantity, and the way that we measure acceleration is meters per second squared. So meters per second, because that's the change in velocity, divided by time. So meters per second per second gives you meters per second squared. Alright, I'm going to talk about those 4 equations later on, but these are going to be known as 4 kinematics equations. What is important about those 4 equations? Basically, the 3 terms that we just talked about, they can be basically used to find one another. Alright, if you know any of the 3 of those variables, then you're going to be able to find any of the other variables by using those 4 equations, but I'm going to talk about that later on. Alright, so we were talking about kinematics. So one way of describing motion is the math, the equations. The second way is that we can actually describe the motion is graphs. And basically xt, vt, and at graphs are going to be used. And another way to describe the motion is motion map. So what is a motion map? It's basically made out of like a scale, like a direction, and dots. And dots basically represent the object. And the idea for that is taking a picture of the same frame over the same time, and then you're going to look at the position of the object at different pictures. So for example, you took the first picture and then you have seen the object at the point that it says T initial. Then the next picture you see that it moved to the left by 1, 2, 3, 4 units. And then in the next picture it moved to left again by 3 units or 2.5. So then you are basically able to tell what is the motion of that object by just looking at it. And another way to describe the motion is verbal, basically. So this is the last representation of motion, simply describing the motion by using the language. And those 3 representations can be used together to describe the same motion. So if you say speeding up, you can describe it verbally, just like we did. You can use the motion map, you can use the graphs, or you can use the equations to describe the same motion. And before we start, we're going to have types of graphs. So we are going to have basically a lot of different types of graph. And when classifying graphs, we need to look at the 2 properties first. And those 2 properties, the direction and the type of the motion. So what is the type? What are the types that we have? So you might be at rest, no movement. You might be going with the same pace, constant. You might be speeding up or slowing down. All right, so those 4. So you're going to look at, are you going positive direction or negative direction? And then, are you at rest? Are you going with a constant speed or a constant pace? Are you speeding up, slowing down? And once the type of the motion and the direction of the motions are determined, then all of the representations can be completed. So once you know those 2, then you can draw all of the graphs and all of the motion maps and everything. And once a representation is known, the other representations can be fine. So like we said, you can describe it verbally, graphically, equation, like by using equations, or the motion map. So you just need one of them. So let's say you have an object at rest at positive location. So how's it going to look like? So we are talking about at rest. So that means position of the object. So if you're at rest, then you are going to be at the same location at all times. So time is going to pass. So time is increasing, but your position is not going up or down. Your position is the same. So you are at rest. So that's how your position time graph is going to look like. And your velocity, since you're at rest, your velocity is 0. And acceleration is the derivative, or like whatever you do at velocity time graph over time is going to be determined by that, like acceleration. Then since you're not changing your velocity at all, your accelerations will be 0 too. And motion map, so if you are basically seeing the object at the same location all the time, the way that we represent it by basically putting the dots on top of one another. And what's the verbal definition? Object is staying at rest at a positive location. All right, so representation 1, representation 2, representation 3. They all represent the same motion. All right, object at rest at a negative location. So how is it going to look like? So this time we are going to be at rest again. So we are not moving. Time is going, but your position is not going up and down. but you are at a negative location. So how is it going to look like? Your velocity time still 0, acceleration time still 0, but this time my 0 mark is at this location, so my position will be on the left side of that 0 location. So what is positive and negative? Actually, let me talk about that. By convention, if you're going to the right, it's positive. If you're going left, it's negative. By convention, again, if you're going up, it's positive. If you're going down, it's negative. And if we need to use the third dimension, like x, z, it's going to be basically out of the page. That's how we show it. That's going to be a positive direction, or into the page. That's how we show it. That's going to be negative direction. And what's the definition? Object is staying at rest at a negative location. And these are going to be the reviews, like everything about it, so I'm going to pass those for the next ones, but you can just go ahead and then read those, but that's going to be the summary of it. All right, object moving with the same pace. So now we move to the next motion type, and our direction is positive. So you are going with the same pace. What does that mean? You are going to displace the same amount. You are going to travel the same distance all the time, but you are displacing now. All right, so your position is increasing, and it's increasing in a positive direction. Then how is your velocity time graph going to look like? Since you are taking the same distance every second, and the velocity is how much distance that you travel in a given time, and since you're traveling the same distance over and over, then your velocity is not going to be 0 this time. You're going to have a non-zero value, but you're going to have the same displacement over time every second. And what about your acceleration this time? You are going to have 0 acceleration, because acceleration is how much you change your velocity, and since your velocity is not changing, your acceleration will be 0. And your motion map is going to look like this. You're going to start from 0 location, and then you're going to go travel by 1 unit every second. So that means you're traveling the same distance every time. And what's your verbal description? Object is moving with a constant speed in the positive direction. All right, those two are important when you're describing the motion. So same idea, but this time you're going to go in a negative direction. So how is it going to look like? This time I have started from 0 location again, but as time goes on, I am going to be traveling more and more in a negative direction. Then my velocity time graph is going to be again constant, but my number for velocity is negative because I am moving in the negative direction. That's what makes it positive and negative velocity. Positive velocity move in the positive direction. Negative velocity means it moves in the negative direction. That's the only difference. Acceleration is still 0 because there is no change in velocity. So what happened for this guy though? You have started from the same location, but you are basically moving backwards. But this time you're moving 2 units backward. So, and I'm not going to go back, but you should recognize one thing. When I had like my velocity time graph, my velocity for the first one, when you were going by 1 unit, it was shorter, but this time it is going to be a greater value. All right, you basically need to recognize that difference. And what's my verbal description? Object is moving with a constant speed again in the negative direction. And that's the summary. Object speeding up, positive direction. So this time I'm going to be speeding up. So what does that mean? I am going to start with some displacement. All right, I displace, but as time goes on, what is going to happen to my displacement? So you started to go little by little, but then as time goes on, your displacement over time is going up. All right, as you can see, this is going to go to infinity. As time goes on, in a really short amount of time, your change is going to be enormous. All right, so that means you're speeding up. And if you're speeding up, basically your velocity time graph will also increase. All right, so your acceleration time this time, since there is a change in the velocity, then you're going to have acceleration. You're not going to have zero acceleration. But since your velocity is changing by the same amount, then your acceleration will be constant. And how is it going to look like? In the motion map, you start, you go like half, then 1.5, 2 units, 3 units, 5 units. So you're basically changing the amount of distance that you travel every second. So to be able to travel more distance in a given time, or in the same time, you basically need to go faster. And what's my verbal definition? Speeding up in the positive direction. All right, it's as simple as it is. So this time you're going to go in a negative direction. So what is happening? So positive, negative, they are only the directions. All right, do not get confused with positive and negative and speed up and slow down. So as you can see, you start the change by little, but as time goes on, you see the differences in between? It's increasing, and if you want to go more, you can go extreme. So in the same amount of time, you're going to basically increase or decrease. So my speed is not decreasing because I am traveling more and more distance every second. But what is going on? I am not going in a positive direction. I just go in the negative direction. So I just go backward. That's what's happening. So my velocity is increasing, but it is increasing in the negative direction. So that's what's going on. All right. So increasing in a negative direction doesn't mean that it's slowing down. Mathematically speaking, 0 and -4, which one is greater? Yes, 0 is greater. But in physics, this negative represents the direction only. So we only look at the number. So 0 is less than 4. So that's why it's speeding up as time goes on. But it is speeding up in the negative direction. All right. And my acceleration time graph this time, what's going to happen, since my velocity is changing in a negative direction, then I am going to have basically negative acceleration. And what about my motion map? I start from 0 location, but what is happening? I travel more and more every second. But what is happening? I basically move in the left direction. And what's my definition? Object is speeding up in the negative direction. Object slowing down positive direction. This is going to be the last type of motion. So this time what's happening? I have started to increase my change. I started with high change in position, but as time goes on, what is happening? My displacement is getting less and less. So if you want to think about it, afterwards it's just going to become constant, right? So that means since it's becoming more and more constant, so that means your position is becoming the same location, which means you're not moving. So that means you are slowing down. So you start with some velocity, positive velocity, because you're going in a positive direction. And as time goes on, you're basically slowing down and reaching to 0. And your acceleration, since you are slowing down, you are going to have negative acceleration. So how is it going to look like? You started at positive location. You started to change your position by large amounts, but as time goes on, you're basically taking less and less displacement. So that means you are slowing down in a positive direction. And how is it going to look like if that's happening in a negative direction? So again, you started displacements with large amounts, but as time goes on, your displacement amount will be less and less. And if you want to go extreme, it's going to become basically constant. So how is it going to look like? You started with some velocity in the negative direction. You see, you're going in the negative direction, so you start some velocity in the negative direction, and as time goes on, you're basically reaching to 0 velocity. And your acceleration this time is positive because, well, that acceleration being positive and negative is kind of complex. I didn't talk about that, but it's about slope of this guy, okay? I'm going to talk about that in the next lecture probably. So since the slope is positive, your acceleration is positive. And how is my motion map looking like? I start from 0 location, I go backward, and initially I was going by like large amount, but as time goes on, I basically travel less and less, and at the end I'm gonna stop. So that's how it's gonna look like. Object slowing down in a negative direction. All right, and that's the summary of that portion. All right, what else do we need to know? Direction of the motion, XT graph. So direction. So as you see, you start from positive, more positive, and then you're going to less positive. So what is going to be the direction of movement for this object? You started at this location and then you're going to another positive location, but you are basically going backward. All right, so as this guy decreasing, you're going in a negative direction. So this is a positive quadrant. So that means your 0 is somewhere over here, but you're still going backward. And what about this? You're starting at a location, at a negative location, and then you end up another negative location, but it is closer to 0. So how is that going to look like? So that's your 0 location. So you start at this location, and then you end up over here. So you are basically going in the positive direction, but you're still in the negative quadrant. All right, so that's basically what you need to be careful about. The sign, so try to understand the motion. Just don't try to go with increases, decreases. All right, try to imagine the motion. And direction of the motion, velocity, time, and AT graphs. So this is important for velocity time graphs if motion is in the positive quadrant. What does that mean? So you have a velocity time graph given to you. So if you are moving in the positive quadrant, then you are going in the positive direction, regardless of this decrease or increase. All right, as long as you are in a positive quadrant, you are basically going in the positive direction. However, if you're in the negative quadrant, then regardless of the decrease or increase, you are going in the negative direction, all right, because you are in the negative quadrant of the velocity time. All right, so that is another key point to describe if it's increasing, decreasing, going in a positive direction, going in a negative direction. An AT graph alone doesn't tell you anything, so AT graphs are not going to be useful. And the last section of graphs, so by looking at the graphs, you can actually get more of that. So change in position, which is delta x. So if you would like to get the delta x, there's another way. If you have a velocity time graph, and if you have the area of that, then you can figure out the displacement in between those two time frames if you get the area under that. Instantaneous velocity. What is instantaneous velocity? It's the velocity at an exact moment. And how can you get that? Basically, at that location, at any position time graph at time t, if you get the tangent line or the slope of the tangent line, that's going to give you the velocity at time equals t. And change in velocity, this time you're going to go with acceleration time, and the area under acceleration time graph is going to give you the change in velocity, not the velocity, change in velocity. All right. So complex graphs, how do they look like, or what do we mean by complex graphs? So you are not going to have just one type of graph. You're going to have basically a motion that is going to be composed of 3 different sections. So how do we describe the motion in those sections? So in this case, you basically divide it into parts that you know of. So you basically have this first part, then second part, and then the third part. So you're going to divide it to 3, and then you're going to describe all of the 3 parts separately, and then replace those or reflect the motion of those objects in different graphs. So in the first part, what is happening? I basically speed up for 5 seconds, and I start from 0 time and 0 velocity, and I go up to 10 meters per second. And I speed up at the same amount. So try to remember the motion of linear velocity. What was the representation of that guy in the position time? So if you're speeding up, you're going to start with some velocity, some position, and then you are going to, since you are taking starting slow, you're going to start to displace less. But as time goes on, you're going to start to go more and more. So that's how it's going to look like. And then for 2 seconds, what are you going to do? You are going to continue to velocity. This is very important. You did not stop. You are traveling, still traveling, but this time you're traveling with 10 meters per second. So I am going to go with the same amount of velocity over time. Alright, so I'm going to have linear velocity position time graph here. So I start with a parabolic. I didn't actually scale it according to, well, my drawing is so bad. So I am going to go until 5 seconds. Let me try to go with the timeline. So you start less and then you start going up, and then for 2 seconds you're going to displace with the same amount. And then, okay, another part, you are going to slow down. So how is it going to look like in the position time graph? You are going to slow down, but you are not going to go down because you are still in a positive direction. So your velocity is still positive, so that means you are going to be traveling more and more, but as time goes on, you're going to have less and less displacement. Alright, so that's how it's going to look like. And your acceleration time graph, since, again, acceleration time is about the slope, the first section you have positive slope. So you're going to have positive constant. In the second section, you basically have 0 acceleration, and the next part, you basically have negative slope, so you're going to have negative acceleration. Alright, so that's how it's going to look like. I know it's too much, but this is basically the core of kinematics, and I will be solving more questions in the next lesson. But this lesson is more about understanding the rules, and these are going to be the rules. And next time I will be giving more examples. And please watch this before you start solving your questions. Thank you.